This video is about review for final. 10A. Colorado beetles are a pest which can cause major damage to potato crops. For a certain Colorado beetle, the amount of oxygen in milliliters consumed each day increases with the temperature as shown in the following table. This information has been used to plot the scatter diagram. Find the equation of a regression line of y on x. So go to stat, put the L1, that's the x, L2, that's y. Then put the diagnostic on in case sometimes we got to use correlation coefficient R. Then you will get y equals 15.5x minus 80. That's over here. For 10b, the mean point has coordinates 20 to 30. 20 to 30. It's here. This is given. Draw the regression line of y on x on the scatter diagram. When you draw the regression line, remember the line has to pass through this mean point and also y-intercept. F of 0, we plug in 0, that equals negative 80. So you have to find the negative 80. That's over here. Each unit stands for 20. Then you have to use a ruler to connect these 2 points. The mean point and also the y-intercept. This is the rule for grading the regression line. You have to pass through the mean point. And also you have to get the correct y-intercept so that you can get the full credit for drawing regression line. Let's go to 10C. In order to estimate the amount of oxygen consumed, this regression line is considered to be reliable for a temperature x such that x between A and B. Write down the value of A and B. Let's talk about the concept interpolation or extrapolation. The interpolation means the area between the domain. Then when you do the estimation in the interpolation range, it's reliable. But for the extrapolation, that means beyond the domain, like from here to here or from here to here. It's beyond the range. When you do the estimation or prediction for this area, it's not accurate. For extrapolation, it's not accurate for the estimation. Therefore, from this table, we know the temperature between 10 to 30. So we can do the estimation using this regression line to do the estimation when x between 10 and 30. If x greater than 30, then it's not accurate for you to do the estimation. Therefore, the A equals 10 and B equals 30. In other words, this x will be between 10 and 30. Then the estimation is reliable. Let's go to 11A. A health inspector analyzed the amount of sugar in 500 different snacks prepared in various school cafeterias. The collected data are shown in the following box and whisker diagram. Amount of sugar per snack in gram state what 13 represents in the given diagram. We know for this whisker plot, this point is minimum, maximum. This will be median. And this is the first quartile. This is the third quartile. So for 11A, we're looking for 13 represent median. 11B, write down the interquartile range for this data. Interquartile, that means Q3 minus Q1. That is 18 minus 12 equals 6. For interquartile range, that is Q3 minus Q1. You can find this in the formula booklet. For 11C, write down the approximate number of snacks whose amount of sugar range from 18 to 20 grams. For the whisker plot, this is 25%, so each is 25%. Therefore, from 18 to 20, you will use 25% times altogether is 500. You will get 125 snacks. For 11D, the health inspector visits 2 school cafeterias. She expects the same number of meals at each cafeteria. The data is shown in the following box and whisker diagram. Meals prepared in the school cafeterias are required to have less than 10 grams of sugar. State giving a reason which school cafeteria has more meals that do not meet the requirement. This is school cafeteria 1 and this school cafeteria 2. For school cafeteria 1, less than 10 gram of sugar, that's 50%. For school cafeteria 2, it's this part, that's 25%. In other words, for cafeteria 1, it's 50% meet the requirements. And for cafeteria 2, only 25% meet the requirements. The sugar is less than 10 gram. So, for cafeteria 2, have more meal that do not meet the requirements. Let's go to 12A. The following scatter diagram shows the scores obtained by 7 students in their mathematics test M and their physics test P. The mean point M for this data is 4016. Plot and label the point M on the scatter diagram. So this point is 4016. That's the mean point. For 12B, draw the line of best fit by I on the scatter diagram. Since for 12b, they say draw the line by I, then you have to pass this M, and also extending the line pass through this y-axis. Just draw the line in the middle of all the points. For 12c, using your line of best fit, estimate the physics test score for a student with a score of 20 in their mathematics test. I will find the 20 in mathematics test is here. Then I draw a straight line, vertical line. Then over here. This will be 9. Let's go to 13a. A transportation company owns 30 buses. The distance that each bus has traveled since being purchased by the company is recorded. The cumulative frequency curve for this data is shown. Find the number of buses that traveled a distance between 15,000 and 20,000 kilometers. You will look at this cumulative frequency graph, 15,000 and 20,000. You will get this point. This will be 20. And this point. For each, this will be 0.5. Therefore, you will get, here's 1, 2, 3, it's 28. 28 minus 20, you will get 8. Let's go to 13b. Use the cumulative frequency curve to find the median distance. Altogether, this is 30. So 30 divided by 2 is 15. So we do 15. Then going down like this. So find the scale. Each small one, that is 500. So you will get, this is 10,000. This one is half of 10,000 and 15,000 will be 10,000 plus 15,000 divided by 2. You will get the 12,500. This is 12,500. Then plus, we go to 2. So 500 times 2. You will get 13500. So median distance will be 13,500. Now let's go to 13c. Use the cumulative frequency curve to find the lower quartile. Lower quartile, that means 25% of this. That's 30. So you will get 7.5. You will get the 7.5. This is a 7.5. Therefore, you will get 10,000. Upper quartile, that's 30, you multiply by 75%. You will get 22.5. So find the 22.5 is here. We know each unit, that's 5,000 divided by 10, you will get 500. So 15,000 plus 500 times 2, you will get 16,000. So answer will be 16,000. For 3E, write down the interquartile range. The formula given, that's the upper quartile minus the first quartile or the lower quartile. Therefore, we have 16,000 minus 10,000. You will get 6,000. Write down the percentage of buses that traveled a distance greater than the upper quartile. We know this is a minimum point. Suppose this is a median. This is a maximum point. And this is a first quartile, and here is a third quartile. We need to figure out the percentage is the upper quartile. That means from here to here. Each one is 25%. Therefore, this will be 25%. We know in the whisker plot, from minimum to the first quartile, that's 25%. First quartile to median, that's 25%. From median to the upper quartile, that's 25%. So remember this fact. 13G, find the number of buses that traveled a distance less than or equal to 12,000 kilometers. So we're looking for the number of buses that less than or equal to 12,000. 12,000. From the graph, you will find this is a 5,000. Each of the unit is 500. For here, that is 0.5. So for the cumulative frequency graph, you have to know the scale like this. So we need 12,000 from here. I will do you minus 10,000, you have 2,000, then you divide it by 500, you can get the 4. From here, 1, 2, 3, 4. This one will be 12,000. Then go here. They will go to 11.5. But the buses, you cannot get a decimal. So you could say it's like 11. Don't put the decimal for this question because we need a number of buses. Cannot be decimal. Go to 13H. It's known that 8 buses travel more than m kilometers. Find the value of m. We see keywords here is more than. So you, from the top, get, this is a 30, go down to 22 because 30 minus 8 equals 22. We know the scale here is 0.5. This is a 20, 21, 22 here. This is a 22. So we draw the horizontal line. Then go down here. We will get this. That is 15,000 plus 500. Each is 500. Multiply by 2. You will get 16,000. So answer will be 16,000. That's the M. For 13I, the smallest distance traveled by one of the buses is 2,500. The longest distance traveled by one of the buses is 23,000. On the graphing paper, draw a box and a whisker diagram. For this data, use the scale of 2 centimeters to represent 5,000 kilometers. From the previous question, we know this is the information we got. 2 centimeters, that means from here to here, that's 5,000. Which means the scale, each one, it will be 500. Very small unit, that will be 500. When you draw this whisker plot, remember you have to show this distance and the scale like this. Then find the points, get the minimum, maximum, the first quartile, the median, and then the third quartile. Then draw a box, connect like this. When you draw this box, make sure you have a correct label and a scale. You have to label as distance and a scale. Then correct median, correct quartiles, and endpoints. 14A is about normal distribution. We know the standard deviation is 5 and mu equals 65. That's mean. Find the probability the basketball player has a weight that is less than 61. So we're looking for the probability is less than 61. Go to normal CDF. We put in like this. And your answer will be 0.212. For 14B, in a training section, there are 40 basketball players. Find the expected number of players with a weight less than 61 kilogram in this training session. So we use this probability 0.212 times 40 equals 8.48. The probability that a basketball player has a weight that is within 1.5 standard deviation of the mean is Q. Sketch the normal curve to represent these probabilities. First of all, you will see within 1.5 standard deviation, you're just using 65, that's the mean, plus 1.5 times 5, or 65 minus 1.5 times 5. So suppose this is a 57.5. Here is a 72.5. Then shade this area. That's the probability Q. Go to 14D, find the value of Q. So we put normal CDF like this. Then you will get the 0.866. Given that probability W greater than K equals 0.225, find the value of K. First of all, remember when you put into calculator, you have to put this is less than k. That's the reason you will get w less than k equals 1 minus 0.225. You will put over here. Then you can get the k equals 68.8 to 14F. This table shows performance versus weight. So performance, we can do y, weight as x. Your null hypothesis is performance is independent of weight. For 14G, you want to get the p-value. So put this table into matrix and then working on the chi-square test, you will get the p equals 0.287. P equals 0.287. 14H state a conclusion for this test. We still use this. The alpha stand for the significance level 5%. So this area is 0.05. Since the p greater than 0.05 means the area will be greater than this 0.05. In other words, it will fall on not rejection region. So it won't reject null hypothesis, HO. Here's the conclusion. We don't reject HO because P is greater than significance level 0.05. 15A. A four-sided die has written on the number 1, 2, 3, 4. The die is rolled many times and the score are noted. This table shows that. The die was rolled a total 100 times. Write down the equation in terms x and y for the total number of times the dice was rolled. So 18 plus x plus y plus 22 equals 100. You don't have to simplify. The mean score is 2.71. Use the mean score, write down a second equation in terms of x and y. Mean score, that's 1 times 18 plus 2 times x plus 3 times y plus 4 times 22 over 100. That equals 2.71. You don't have to simplify. This is the second equation. 15C, find the value of x and y. First of all, you have to change each equation into y equals form. Because we're looking for x, y, that we have to solve this system equation. This is 1. Then the other one, you will get this. So we go to calculator, plug in. We put y1, y2. Then we set a window like this. Because we do know the domain for x and y, that will be between 0 to 100. That's the reason I set up the window like this. Then I get these two graphs get an intersection 15, 45. Therefore, x equals 15, y equals 45.